Okay, so question for you. Which weighs more, a kilogram of feathers or a kilogram of lead? All right, if you answered lead, then I managed to trick you. See, I asked you a question about what weighs more, and I told you in the question that both the feathers and the lead would weigh 1 kilogram. So they weigh the same is the actual answer to that question. If I tricked you, what you naturally did was rewrite the question in your head to ask yourself, what is more dense, a kilogram of feathers or a kilogram of lead? Now, the answer to that question is that the lead is more dense than the feathers. All right, so let's talk a little bit about density then. What is it, first of all? Well, if you take the same volume of different substances, then they're going to naturally weigh different amounts. For example, if we compared 1 cubic centimeter of wood, that means a little cube of wood that is 1 centimeter wide by 1 centimeter high by 1 centimeter thick, we would have 1 cubic centimeter of wood. All right, if we took the same volume of water or iron, they would all weigh different amounts. For instance, the wood would weigh about 1/2 gram. The water would weigh 1 gram, and the iron would weigh about 8 grams. So in this case, which has the greatest mass? Because these 3 samples all have the same volume, in this case, the greatest mass would represent the most dense of these objects. So which is the most dense? The iron, obviously, is the most dense in this case, but only because they all have the same volume. That's because density is the mass per unit volume. Let's have a look at some math. The density equation looks like this. Density is equal to mass divided by volume. Now, the mass will be in units like grams or kilograms. The volume will be in units like cubic centimeters or cubic meters, or maybe something like milliliters or liters. The density then will have units like grams per centimeter cube, or kilograms per meter cubed, or grams per milliliter, or something like that. Now, if you were to see the density equation printed in symbols rather than in words, it would look like that you see on your screen now. Notice that that isn't really a P, not quite. It's close to a lowercase p, but what it actually is a Greek letter called rho, and that's the standard letter that we use to represent density. So the equation is saying rho is equal to m divided by v. The rho stands for the word density, the m stands for the word mass, and the v for the word volume. Now, in order to help you remember that, you can put it all into one of these handy mathematical triangles. The way the triangle works is that you use your finger to cover the letter that represents the thing you want to know. So if you want to know the density, then you put your finger over the rho, which is in the bottom left-hand corner of the triangle. And the triangle tells you that you need to put your mass on the top and to divide that by your volume. On the other hand, if you knew the density and the volume and you wanted to know the mass, you just need to rearrange the equation. And the triangle tells you how to do that. You cover up the m with your finger, and you read the triangle. The triangle says rho times v, so that's density times volume. And so the triangle will always help you to remember the way that it will always help you to be able to work out how to rearrange the equation so that if you know any 2 of those volumes, you can always find the 3rd. All right, we're going to practice that quite a lot when I see you in class next.